Hello! In this video, we are going to prove the following theorem. Suppose A, B, and C are real numbers. If A is greater than B and B is greater than C, then A is greater than C. Now in this series, we are using a list of 10 axioms for the real number system, and I'll leave that list of axioms in the description below. Now, before we get into proving this theorem, we are first going to prove a preliminary result. And that preliminary result is as follows. Suppose A, B, and C are real numbers. Then A minus B plus B minus C is equal to A minus C. Now, to prove this result, we are going to be using the following axioms. Axioms 1 and 2 are just the commutative and associative laws. Axiom 4 tells us that there exists a real number, which we call 0, that has the property that x plus 0 is equal to x for all real numbers x. And Axiom 5 tells us, for all real numbers x, there exists a real number, which we call the negative of x, that has the property that x plus the negative of x is equal to 0. Now also, our definition of subtraction is as follows. Suppose A and B are real numbers. We define A minus B to be equal to A plus the negative of B. Okay, so now let's get into proving this preliminary result. Now, to prove this preliminary result, we're trying to prove that these two guys are equal. And to prove that, we are going to establish a chain of equalities showing that these guys are equal. And through that chain of equalities, we are going to be applying axioms 1, 2, 4, and 5, and the definition of subtraction. First of all, applying the definition of subtraction, we have A minus B equals A plus the negative of B, and B minus C equals B plus the negative of C. And then, applying axiom 2, we can move these parentheses around A plus the negative B plus B. And then, applying axiom 2 again, we can move the inner parentheses around negative B plus B. And then, applying axiom 1, we can swap negative B and B. And then, by axiom 5, B plus the negative of B is equal to 0. And then by axiom 4, A plus 0 is equal to A. So we have A plus the negative C, and then by definition of subtraction, A plus the negative of C is equal to A minus C. And so through this chain of equalities, we have shown that A minus B plus B minus C is equal to A minus C. And that is exactly what we wanted to show. So this proves our preliminary result. So next, our goal is to prove this theorem. But before we do that, let's get some more context. Now, our real number system is equipped with a subset, which we call the set of positive real numbers. And it is denoted by R plus. And one of the axioms that we have that is associated with the set of positive real numbers is as follows. Axiom 8 tells us, for all positive real numbers A and B, we have A plus B is a positive real number, and A times B is a positive real number. Now, in proving this theorem, we're only going to need to use the fact that A plus B is a positive real number. And using the set of positive real numbers, our definition of greater than is as follows. Suppose A and B are real numbers. We say A is greater than B if A minus B is a positive real number. Okay, so now let's get into proving this theorem. Now we're trying to prove if A is greater than B and B is greater than C, then A is greater than C. And to prove that, suppose A is greater than B and B is greater than C. From here, the whole goal is to show that A is greater than C. Now, by definition of greater than, since A is greater than B, this means that A minus B is a positive real number. And since B is greater than C, this means B minus C is a positive real number. And then, by axiom 8, we know that the sum of two positive real numbers is a positive real number. So, since A minus B is a positive real number, and B minus C is a positive real number, that tells us the sum, A minus B plus B minus C, is a positive real number. But, according to the preliminary result that we proved, A minus B plus B minus C is equal to A minus C. So, because this guy is a positive real number, that tells us A minus C is a positive real number. But then, by definition of greater than, since A minus C is a positive real number, that tells us A is greater than C. And so, we have shown if A is greater than B and B is greater than C, then A is greater than C. And that is exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.